Hey everyone, welcome back to the channel. Now, anybody who's been following any activity that's been going on my channel so far, you'll be well aware that over the past 2 weeks, a lot of it was dedicated to the EXO Games, which is a phenomenal success, by the way. And everybody who was at the event, it was an absolute pleasure to have you there. Super excited what's going to come next. And yeah, it's been super cool. Anybody else who was following pre to this, you'll know that we did the Tomb Raider axe, and this was setting up to a precursor to something bigger, something that we're really going to aim towards. And this, what I'm going to start off is a project which will turn into many videos. I'm going to try and keep the videos as short as possible to set up what we're doing. This will not be solved in a couple of videos, and this will need a lot of support. So anybody who's interested, anybody who wants to get involved, or anybody who wants to offer some insight to this, please do reach out, let me know, and I'll reach out to others. First things first, let me explain what this project is. This is known as the Hardyman project. So on my other screen, I have a lot of videos, well, a lot of examples I'm going to bring up. So this goes back to the 1960s. Now in the 60s, this was a project which was funded by the American military, GE, and the Office for Naval Research. This project was insanely exciting. This came from 65 to 1971. This project was dead simple. What they wanted to be able to do is they wanted to be able to offer an exoskeleton structure that an operator, a pilot, would wear around the body, and he could interface. He could be like a human forklift truck, in lack of better words. It's very rudimental, my description for this, so I'm going to give you some more references as we're going through. And this project sadly never got to fruition at the point of where this actually became an operating piece. However, what you should be able to find when you type in Hardiman is lots of reference images. A great place to start with reference to this, if you are interested in the history and where this has actually come from, is starting with the ASTM Excellent EXO chat. Bill and Nora actually covered what happened to Hardyman, and they give a great description, a great overview. So if you've never come across this podcast, do give it a shout, do give it a reach out. It is a great podcast which covers anything to do with robotics and also exoskeleton technology, all from Bill and Nora, who are of the F48 of ASTM. So great, really good reference if you are interested in this a little bit further. So let's get to the black and white of this. When this project took off, this project, they did hit some few issues with it. What they wanted the pilot to be able to do is, if they're coming towards something, not be able to interface with the door, not like smash through the door. They wanted the pilot to have feedback, some haptic feedback as they were interfacing with the world. And what they also wanted the thing to be able to do is to support an awful lot of weight. Now, when they were using, because they were using servos, and really nowadays we use a whole range of different actuator methods, but they were using servos to actually support the operation of this. For 1965 is insane that they got this far. Some of the problems that they faced, they were overcoming problems that we still to this day we are really overcoming now. Ralph Mosher, who is an American inventor, worker at GE, has been coined as being one of the fathers behind all this. Fascinating individual to learn about if you are really interested in some of the work that he's done. But yeah, let's move this forward. What am I attempting to do? What is it? I shouldn't say I. What are a few of us attempting to do? Well, this story gets a little bit hazy. So they ran the project itself. Now, what I'll do is I'll just jump across to some of my files. This is my little homework file. Now on here, I have notes, all the published reports that I could find. These are all available on the internet, so it's nothing sophisticated that you're seeing here. However, what is interesting with some of these reports is they did get to the point of where they found issues with it. They found that it would randomly move quite aggressively. They always knew that they couldn't actually get a human being in the machine, and they also knew that once they get a human being in the machine, it would be potentially dangerous. So they actually drew a line at it. However, what you can see in these very rudimental, these poor scans, is there was something completed. There was a structure made, and once this was completed, the problem is one second, let me just pull to here. This one's a good one. These images were taken. Now, the thing to remember is this on the right, with the man himself actually in the exoskeleton. The thing is this for definite was never turned on because of the threat of this spinning out of control. Now, what a lot of us are wondering is this is GE. GE are very efficient, and they're not ones who just simply scrap something and throw it in the bin.
Music licensing reimagined.
One interesting thing is what actually happened to this? Where is this? And what I wonder where this could actually be. That's a little bit of a side note to what I want to do. Now, once we actually come back to the actual files itself, these sets of notes that we're going to go through. Let me just find the right one. If this is the right one, is this the right one? Please be the right one. Oh, this could be the right. So if I just pull this down a little bit, what you'll notice is drawings, pictures, they are barely usable. You can barely actually see exactly what was going on. And all the technical drawings that are actually in these documents are unrecognizable. It's almost heart-wrenching to think all of this work had gone into the actual development of this world's first exoskeleton. I should say world's first powered exoskeleton. And yes, it's completely unrecognizable. So what can we do? Well, there is things we can do, and there is things we are going to do. What we can do is use some of the techniques that we'd learned in some of the earlier sessions that we've done. So take this for example. You can actually see an awful lot in just this image. Don't forget, we used some techniques to recreate the Tomb Raider axe. If we look a little bit closer, you can see here that his arm is to elbow at this point. So this arm to elbow is purely to this point. Exactly where his arm finishes, we can even figure that out. However, what we're looking to try and do is start recreating just some smaller sections here. Now, average, now let's have a look. So we need to try and figure out roughly what sizes would be. So the average male, average USA male, 1965. Let's have a look. So according to this, in the average heights, in 1965 was around 175.3 centimeters. 175.3 2 feet inches. So it's roughly 5 foot 8 inches. If I round up, so if I round up, this goes 5 foot 8 inches. So 175.3. Okay, so I pulled this out earlier. This is a fab website. This is the An Atom for Sculptors. Now what we can do with this is to give us a rough height and size of how things are going to be. We can actually figure out where somebody's shoulder should be and roughly what length would be. By using something like this, we can figure out where Ralph's elbow moves in and how far it actually moves down, because we can figure out roughly what the length of his elbow would have been. Now, there are other images as well, and if you are interested in these images, please do ask and I will share these. These are about, I found these images on Pinterest. Great reference point for imagery. This is one image that came off Pinterest, which I'm sure has actually come from somewhere else as well. But this was a great start to give us a rough idea. The idea here is, can we rebuild Hardyman? And can we bring some of these dimensions back to life? Can we actually get some of this back going again? As you'll see here, now if you look there, you can actually see if this is based on the genuine Hardiman, look above where the hook is. This is a lower piece here. So if we come back to the actual, oh, this is another great. This is Cybernet Zoo. If we look back to the original imager, that's not 100% clear where that's all sitting, but it appears that that's actually sitting on the outside. So if we just come back to the image again,
Artlist.io.
That's actually sitting round, isn't it? So if we just take another hit back, see, the problem is when you face any of these is it's always going to be a little bit of hit and miss. So what I'm doing here is I'm going to use Inventor this time. Inventor, if you've not used Inventor before, it's a fabulous software. It is just like SolidWorks. And what I thought I'd do is just spin this up and go the other way this time. So I'm going to go new. And in this case now, I'm going to create a standard Inventor part, IPT. What I'm going to do here is I just want to establish my first iteration, the sizes. Can I actually get this roughly working as I want it to? Now this image, which is this image, I've actually downloaded as a JPEG. So if I now come back onto my Inventor section, I'm going to come to my XY positioning and I'm going to go sketch. Again, anybody who's not used to Inventor, it is a fab software. Now, what I'm going to do is bring in my sketch image. Now, I'm really particular with this. I'm a real pain in the backside with this. So this is the GE dimension, and bring this down. And I'm just going to put it something like that. I'll put it there. So you see there how it's come in. Really, I'm going to start to move things around, but I'm just going to put that there for the moment. What I'm looking to do is to set myself up some references. The average height of males in the 60s is 5'8". So if that's what we're looking for, so that means we're going to look at that between base of his foot to here being an average height of 5'8". We're then going to use that reference to allow us to set up a baseline of where everything will sit. Really, I could split this in half and actually put these over the top of each other just because they are pure references, but we'll get to that. What I'm interested in at the moment is just setting myself up with a nice piece. Now, the other thing to remember is 175.3 is what we'd essentially said. So if I go 175, let's go 175.3. Right, so you see now we've got different sizes that have emerged here. This is, as I said, this is a fantastic software to give us rough sizes of how big something is and where actually everything's going to sit. So if we look there, we've got width of shoulders, and that's just a central point to the middle. So that gives us a rough idea. Now, to do this any justice, we're going to have to build all this up. So what I'll do first is I'll exit the actual piece and I'll go on to my XY drawing. From my XY drawing, what I'll do is come onto my line, and I've just put another sketch on here, by the way. I'm going to do a center line. My center line, This is just laying it out. On here, I'm going to go over here, and the height of this right now is going to be 175.3 centimeters. 175.3 centimeters. Okay, so that's going to be my height. Don't forget, it's actually there to there that I'm chasing. It is not the entire of the operator. Well, it's not the entire of the image, I should say. Okay, the next thing that I'd like to do is, based on my image point here, I'm just going to look at the head height. Now the head height, let's have a look to chin. So what we'll do is we'll do a head and chin of what, 29.4. So what I'll do from here is come onto here again, and I'm going to set a line and go here like that. That sets me a key point here, and I'll do a point of symmetry, U, and U. Now this now becomes between top to here and here. I'm going to turn this into 29.4 4 centimeters. This now pops that head straight down, and I've now got that key reference. Given the actual distance where we're at now, so this now puts us into this whole length here. Now we're just saying that we have the width of shoulders. Width of shoulders 43.9. So if I, again, you can see where this moves. It is so easy to do. So if I go 43.9 centimeters. Now, I don't really need to go much more than that. This allows me now to just have a rough idea where the body's going to sit. So if I need to, I'll come back to that image. But what I'm just going to do is I'm going to drag this up now, because I want to just manipulate the imagery that I brought in. What I'll do as well is I'm going to rename this and just call this my prop. So my anatomy proportions. So bring it up for my anatomy proportions, and I'm just going to call this ref im, or ref image. Just gives me an idea of exactly what I'm doing. As you'll know, if you followed any of my tutorials so far, I'm a stickler about just referencing things. Well, I mean, just changing things where need be. It will help you in the process of everything that you're doing. So what I'm going to do first is I'm going to come from this point here, and what hang on, let me come back. Go, no, stop on here. I was racing there, apologies. I'm going to go scale. So from my scale now, I select onto the actual image, and then I'll go base to point image. Anybody who uses SolidWorks, same process, not much different. And for this point, I'm going to take a guess of 4.3 and go apply. Oh, that actually didn't work for me at all. So onto here. Is there anything we would like to get? Yes. So I'll just go 4.
Artlist.io.
Right, let me just check. What are you complaining about here? Okay, so it's probably to do with how I brought that in. I'm just going to rebuild that on again. Yes, I have had that come up before. I don't like to mess around though, so what I'll do is go back in and go to my Hardiman image, go into here, and then pop it onto just there. Then what I'll do is go to scale. 1 second, I just realised I've still got something open.
Artlist.io.
Okay. Nope. Sorry, I just realised something else is on as well, and that's going to cause me problems. So I'm just going to come onto now, and then from here I'm going to hit scale, and come onto here, and then set here, and then go 4. See if that does it. Now you see there, it's because I had something on. You see how it's now illuminated here. That's a good sign. It means it's actually doing what I want it to.
Music
So then we've got 8.
reimagined.
I'll go 10. Let's go 12. Let's just go on 12 for the moment. I'll go apply. Okay, now you see there that's completely incorrect. However, what we do see is this line needs to be aligned up to here. So I'm going to simply move this image. So come on here and then move to here. Now the thing that's going to wind a lot up on this video is this is really not an exact science at all. What we're trying to do is we're trying to rebuild from any types of insight that we can get. So doing this can be very, very tricky, and doing this correctly can be not just tricky but bloody frustrating. So it's going to bring that down slightly, and you see there it's not too far off. Yeah, now if I bring that back over, what you'll actually see is that my reference now, he needs my little scale piece here needs to be made even bigger. So what I'll do is again use this point as a reference, and then I will just go up. Let's have a, whoa, not that much. So let's just go 1.
Artlist.io.
Oh, no, not 2. Go 0.5. Ah, no, that nearly went wrong for me. 1.1. Yeah, so I think even if I do go 1.1, so 1.5, that's still going to scale the upper arm to the position. So if I go 3, that may just pop it nicely into.
Music licensing.
Oh, so close. And again, thing is here is it's not an exact, but I need to give myself as much as I can to, if this is going to work, I need as much as I can as reference goes, because you got to remember in this the hardest thing that we're facing is there is no references at all. We have nothing to do this, so we're actually making this up based on whatever evidence we can find to do with what is out there to support what we're trying to make. So let's go 1.1. Oh my goodness, that is close. That is close. I'm still just going to be a little bit difficult there, so I'm going to go 1.1, 2, 1. Let's go 0.5, 2.5. See, I think 2.5. Oh, now look, this is good. Because if I look there, you'll see there it's actually just slightly up. So I think we've actually got it. I think we've got the image size that we're looking for here. So if I now pop this down, bring it over a little bit here, and then just pop it to there. Bingo. We got it. I'm pretty confident with that. So what I'd like to do now is move this and now do the same thing a little bit over. So I'm just going to pop it over, and our example is going to be
music licensing reimagined.
Ooh, a little bit more. And again, this is based on Ralph Mosher actually being of that standard average, which is a little bit of a guess, and it's a massive guess, let's face it. But what you'll start to see is, you can see there where it's starting to line up. What we're getting now is a proportion that we can actually make this. We can recreate the lost images. And don't get me wrong, our units, our dimensions that we create as we're moving along on this small project will be a little bit hit and miss. However, that is exciting. If you look there, we've now got shoulder, we've got height, we've got the height to here, and what this now tells me is anything that we start to generate and start to create, we have some great reference images. So this is our first iteration of the Hardyman. Now, again, this project is not going to be short. This project is going to go on for a long time. In fact, I'm going to even get as many undergraduates I can find to get involved with this. But this is our first step. And if I just come out of here,
IO.
and I'm gonna now change this, and I'm just gonna call this ref image. Now what we've got, this is looking good. This means that if I now pull this image and we look across to here, what we've actually got now is we've got a rough reference as to where this is all going to sit. We can now even start to look at, I'll zoom that in, we can now even start to look at these key points around here. So we're going to use as many imagery that we can find. Again, if anybody would like to have a shared access to my drive, so to this area that I'm publishing, please do let me know. More than happy to give you as much access as possible. Any key dimensions we can get, let's get them all on there. Let's get Hardyman rebuilt, because he is an amazing feat of engineering that was completed through history, and if he gets lost in time, it will be a travesty. And anybody who's involved in exoskeletons will know how important Hardyman is. So let's get him, let's bring him back, and let's rebuild him. As I said, that concludes the first real part of setting up our sizing. This is our reference image. So as ever, what I'm going to do is save that. So it's going to ask me where do I want to save it. I'm just going to save this on my. In fact, I will save this. I'll save this on my desktop. I'm actually going to save it on my localized drive, but I don't want to show you my localized drive. So I'll call this Hardyman. We're going to start with this just because we need to build it up as a solid piece, break it down similar to like we did with the axe. We're going to start with how GE did it. Now GE, what they did is they started with the arms. Our first project, our first iteration in this is going to be the arms. I need to get some more imagery. I need to get some more insight for it. But yes, our next step on this case is going to be the arms. And that concludes the first initial step of setting up. I hope you found this useful. I hope you find Hardiman just as interesting as I do. And other than that, have a great day, everybody. And I will speak to you next week. Cheers, guys.